let's start. Do I need to prepare anything still? Okay, it's not. Okay. Hello, everyone, and I hope everyone can hear me. And welcome to this competitive programming workshop, C++ for competitive programming. In this workshop, I'll be teaching you from scratch the part of C++ that you need for competitive programming, which, to be honest, is quite a small subset of the entire C++. C++ is quite complicated, and we're not going to go through all of that in 2 hours. So just a bit of background. C++ is pretty much the default programming language for competitive programming. There's also Rust, but Rust isn't really supported by most of the programming competitions. There's many advantages when it comes to using C++ for competitive programming. One thing is that it's very fast. I think it's about 100 times faster than Python and 10 times faster than Java or something. So that's one advantage. Another advantage is that it has a very good standard library. So many commonly used data structures you can find in the C++ standard library. This is unlike C, which has nothing in the standard library pretty much. So if you want an array list or a hash map and you're using C, but you basically have to write it yourself. Whereas with C++, you can just use whatever is available in the standard library. So that's definitely very important for competitive programming. You can see all the content here. First of all, I'll go through all the basic syntax just to get us started, all the variable declarations and control flows and functions, etc. And then I'll go through what is pretty unique to C++ and C, and that is pointers. If you come from another language, maybe you haven't seen this alongside with arrays, both static array and dynamic allocated array. I also briefly touch on memory management in C++. This isn't that important for competitive programming because most of the time they don't really care about whether you have a memory leak. But sometimes you do have to be careful because you might get the memory limit exceeded if excessive amount of memory are being leaked while your algorithm is running. So for example, if you allocate some new memory every time you call a function, but you don't free them, and if you call that function many times, you might get a memory limit exceeded. After that, I'll talk about functions and template. Function is pretty important because you probably want to organize your code. You probably want to have them if you're doing the same thing many times in your code. And function template is just something that you pretty much never write yourself, but you often come across it in the standard library. So I think it's important that you understand how a function template works. After that, I'll talk about classes and class templates. Just in case you want to create some custom data structure, you definitely need a class. Also, knowing how to create your own class will definitely help you use some of the classes in the standard library as well. And again, that's why I'll very briefly talk about class template too, just so that you can better understand all the template classes in the standard library as well. And then after that, I'll dig into the very massive C++ standard library and talk about a very tiny subset of it. The part I think is most commonly used for competitive programming. Obviously, with the standard library, you can just Google and look up the documentation. But and I think you should look up the documentation when you're coding, just in case there's something that you don't know or there's something that you remembered wrong. It helps to double check. But obviously, you can come to this workshop just to get told to look it up. So I mean, everything taught in this workshop can be looked up. So yeah, that's why I'm putting some standard library in this workshop. This workshop does assume that you already know at least one statically typed language. So statically typed means that you have to declare your type whenever you declare a variable. An example of a statically typed language is Java. Another one is C. An example of a language that is not statically typed is it's Python. So in Python, you never have to declare variables type. In fact, most of the time, you just never mentions type in a Python program. So yeah, if you only know Python, this might be a bit hard for you. This workshop also assumes a general understanding of class or struct, at least in the second half of the workshop. because we are going to talk about syntax of class and get into some of the standard library of C++ towards the end of this workshop. I don't think we have enough time to expand the concept of the class from the ground up. So yeah, that's why I'm assuming you already have seen class in other languages. Feel free to fire up Visual Studio and code along with the slide and see the output for yourself if you type really fast. And if you have Visual Studio installed, you can use some other IDE, of course, if you want. Right. So I hope everyone can see that slide clearly. This is a very tiny example of a very tiny C++ program. Some people might have already guessed what it does. It basically takes a single integer input, right? And it outputs that integer multiplied by 10. I'll just very quickly go through what every single line does. On the top, where's my cursor? On the top of this code here, we see two comments. The common syntax of C++ is very similar to those of Java, C, and many other languages. As you can see here in C++, everything after // and new line are considered comments, and everything between the /* and the */ are also considered comments, right? So here is a single line comment, and here is a multi-line comment. After that, there is include IO string. This is basically to include the standard input and output library for C++, IO string input output string. Right, so that's, you have to have that if you want to take any input or print out anything. After that, there is using namespace std. This is more or less just a boilerplate. The reason why it has to be there is because otherwise you have to type std : in front of everything. So as you can show here, if we don't have using namespace std, you have to type std : cin, blah, blah, and it's just very tedious. So you don't really need to understand what a namespace does. It's not really relevant in terms of competitive programming anyway. And for now, just remember you have to type this line. After that, we have the main function. This is the entry point of every C++ program. If you have done C before, this is identical to the C main function. If you've done Java, this is basically the public static void main in Java. So every time you start a program, it starts executing this function first. Right. After that, enclosed in the curly braces are the content of the main function. So these are the statements that will be executed when the main function is called. Most of you here should be fairly familiar with curly braces. The vast majority of statically typed language uses curly braces in their syntax, and curly braces in C++ are pretty much identical to Java or C. So on the first line of the function, we see int a, semicolon. This is basically declaring the variable called a with the type int, meaning integer. Again, this is identical to how it's done in C, C#, Java. So most of you here should be very familiar with the syntax. I'll talk about variable declaration some more a bit later in the presentation, along with types, etc. After that, we see the input line. This is actually something that C++ does particularly well. It's extremely intuitive. And what it basically says is take the console input, cin stands for console input, and chuck it into the variable a. So whatever is inputted into the console, chuck into it. So this is so elegant, even the arrow is pointing. And here's my mouse. I keep losing it. Even the arrow is pointing the correct direction. The arrow thingy is actually called a syntax. It's actually a syntax called operator overloading. So that's something that I'll get to later when I eventually talk about classes. It's probably the most elegant part of C++, in my opinion at least. And it just makes everything look super pretty and intuitive. After that line, we see the output line. Again, this is very similar to the input line. What you see here, I just take a times 10 and put it in the console output, right? C out console output. And then after that, put a new line character. That's the NLN line there. into the console output as well. Again, this is very intuitive, and I'll talk a bit more about console input and output in C++ later. Also notice that at the end of the 3 lines in the main function, there is a semicolon, right? The thing with C++ is that it doesn't really care about indentation or new line character. So you can actually write the entire main function or a single line, like it doesn't care. As long as the semicolon is there separating everything, and the curly bracket is there defining the boundary of stuff, C++ will understand what you're talking about. Right. C++ has many types, but in terms of primitive types, so this is the type that isn't defined by the standard library or the programmer. We have some integer types, some floating point types. So that's type with the decimal point. Char, meaning character, which is actually also a very short int, as you'll see soon. And Boolean, which can either be true or false. Here on the right, we have a massive table that I stole from the internet that lists all the integer types of C++. We have short int, unsigned short int, int, unsigned int, long int, unsigned long int, and long int, and unsigned long int, a whole list of them, right? The only differences between these types are the range of number they can express, right? So for example, for unsigned short int, you can basically express anything that can fit into 16 bits, right? So that's 0 to the 2 to the power of 16 minus 1. Any positive integer that is smaller than 2 to the power of 16 can fit into an unsigned short int, right? In terms of short int, so that's the signed version of an unsigned short int, half of the range get allocated to the negative part of the integer. So we get negative 2 to the power of 15 to the power of 15 minus 1. Now, normally in competitive programming, in terms of integer types, we just choose long, because why not? It's not like one variable is going to give you memory limit exceeded. But if you're going to have a extremely large data structure, say a very large 2D array, then you do want to put some thought into what size of integer you want to use, right? You might not want to use the biggest size there is out there.
Hey, John, can I ask some question?
Oh yeah, sure.
So if I think this table is out of dated.
Oh yeah.
So in C++ nowadays, if you use int, it should be 32 bits rather than 16 bits. And then long will be 64 bits.
Yeah.
It can simply to verify that if you use the size of int and output the value in a small program, and you can see that actually it is 4 bytes, 32 bits for int.
I know. You can see like there's like the C++ standard specify the least amount of bits that the type have to have, and then depend on each implementation, you have different different sizes. So for int, as you've said, yes, 32 as shown here, and 16 for long int. So that's that's something that I was gonna get to like right now actually. But thank you for asking that question.
Sure.
All right. So as Junhao just said, another thing about variable size in C++ is that it's partially implementation defined. So int on a 32-bit system might have 32 bits. It might not be the same as int on a 64-bit system. So this is just something for you to keep in mind. There is a minimal size for all integer types. So in your long is at least 64 bits, for example. Now, floating point. There's 3 floating point types in C++. Float, double, and long double. I've personally never used long double before. I honestly didn't even know it existed. But yeah, basically the way floating point works is that it uses a part of its memory for the significant figures. And so that's the actual number itself. And another part of its memory for the position of the decimal point, right? So as you can see here, float has about 7 to 8 significant figures. And the position of the decimal points ranges from 10 to the power of 38 to 10 to the power of negative 38. And double have about 15 significant figures, and the position of the decimal points ranges from 10 to the power of 308 to 10 to the power of negative 308. All right, char. Char holds a very small integer, usually representing a single character on the ASCII table. So that's the table on the right that maps numbers to characters. You can use it as a very tiny integer if memory really is a concern. And it has an unsigned version as well. If you want to type a char constant or char literal, you simply type the character. Surround it with single quotes. Here's char literal, single quote A, single quote, as example here. After that, we have Boolean. This one should be really simple. The only two value a Boolean variable can hold are true or false. And it's declared like this. Should be this one should be fairly straightforward. Right. Now, just before I move on, here's a small trick that some competent programmers like to use. Define LL as long. What it does is it basically it makes you type a bit less. So instead of long, which is a fair bit of typing, you just type LL, and the preprocessor will replace every instance of LL with long. You can use type diff as well. For those that know type diff, it will basically do the same thing, mostly. Right, so hopefully that's all relatively straightforward. Let's move on to standard input, output, and string literal. If you want to write a piece of string literal, enclose it with double quotes. That's basically it. String literal, double quotes on each side, not single quotes, double quotes. You can also print a string literal, so we can see hello world here will be printed. Now, another thing that's interesting about cin and cout is that you can actually stack, you can stack them together with the arrow thingy, also called the insertion and extraction operator. So that's these things here. You can stack them with them, right? So here we see that you can take two inputs and store them in A and B with a single cin statement. And then after that, we see that you can take some string literal and variables and new line characters and string together to create one massive cout statement. I've split this statement into multiple lines just so that it will fit on the slide. And also, this is just a reminder that C++ doesn't care about new line characters and indentation in your code, as long as you put the semicolon in the correct places, as I said about 6 slides ago. So all the indentation you ever see in C++ is for formatting purposes. I'll talk a little bit more about string when we get to the string class in the standard library. So right now, we're only talking about string literal, right, which is basically sequence of char. With string class in the standard library, we can do a lot more string manipulation, and it really enabled us to do a lot of interesting things.
Hey, Sean, can I give some remark here?
Yes.
So the first thing is that for the main functions, in general, you should put a return at the end of the program.
That's true. That's true.
This is not entirely standard at the moment in your example. There is
most of the time.
Yeah, and also but that's fine. It doesn't matter. And then what I'm trying to remark it is that from my experience, the standard I/O would be faster than the cin and cout. This is because cin and cout in the underlying implementation, it will involve a certain of object creation and disconstruction. Okay. So do you know what the standard I/O, stdio?
Is
and then you use scan and print instead.
Oh yeah, I know the C star scanf and printf.
Yeah. So this
I know their existence.
Yeah, the efficiency between them can be huge. If you have a large input and output.
I didn't know that.
So, but in the competitive programming, I can anticipate that the input will not be that large. But in some research experiment, the input can be as large as some terabytes or something. Then the difference comes huge.
That's
Okay.
true. I just thought
Yeah.
I used to use scanf and printf all the time, but I just thought like seeing and cout is like more convenient. Also, most of the time you're taking very tiny input. That's why
Yeah.
I
So maybe here I can get back to Rob's questions in the chat. What if you type a instead one in when you see in an integer? So by the ancient code, you will get 97 as the integer to the parameter a variable a here. And then this is because they in the cin it operates it first load some bytes from the stream input stream, and then it will map the type of the variable, and then to translate it into the certain part. So this is some type of transforming here. So, but if you use a scanf and printf, then you have to specify whether it is a decimal or not, and then you would know it immediately without this type checking or something. I may be wrong, but this is my my understanding so far. So maybe you can check it if I'm not correct. It would be appreciated if you can let me know to update my knowledge.
Yeah, so you're saying that if you're typing an A instead of a 1, then it should print out an error, right? Or should it have some other bit? Because I actually don't know. I've never tried this.
So in general, it depends on which maybe it depends on which platform you are running. In sometimes if you type a character a, it will implicit, but you want to store this a into an integer, it will implicitly to translate to change the type of this variable into the integer, and then by according to its ancient code. The ancient code of A, it is 97, if I remember correctly.
97. Is it 97? It's like, holy shit, you remember? I don't remember this. Nice.
97, and then it will store 97 in your integer variable in the program. But I would not recommend this. It is too risky to rely on the platform rather than yourself. It would be always the best if you can have the control of everything in the program.
That's very true. That's very true. Some great remark.
Yeah, just some remark. Okay, you can keep going. Sorry,
All right.
I talked too
no,
much.
it's okay. It's okay. It's okay. We have time. We're still on time. Yeah. Am I on time? What's the page number here? Oh yeah, I'm on time. Reasonably on time. All right, let's move on and talk about operator. Let me just, okay. Here you see all the arithmetic operators for C++. You have already seen one of them, the multiplication operator just then. This should hopefully be all quite straightforward. We see plus, minus, multiply, divide, and the remainder operator. Here's a piece of code showing them working. Here's the output. And yeah, I'll talk a little bit about what happens when floating point and integer division in C++. So basically how it works is that if both sides of the division operator are integers, then you get integer as a result, right? As you can see here. If one of the side or both sides are floating points, you get floating point as a result, as you'll see here. And in fact, this applies to all the arithmetic operator of C++, I'm fairly certain. The result will always be whichever one has the most precision or the most range, right? So if you have a short int and a long int, the result should be a long int. And if you add a double with long int, the result will be a double, I think. Right. Now, what if you have two integers, but you want your result to be a float? What do? You can convert or cast that integer into a float. So the syntax for casting is very simple in C++. You just put the type that you want to cast into the bracket in front of the variable. You put the type you want to cast into in the bracket in front of the variable, and C++ will convert the variable into desired type. So here you can see if you do a division with the first variable cast float, you get float as a result. The assignment operator, you might have already noticed it 2 slides ago when I assigned 7 to A and 2 to B. It's just the equal sign, should be very straightforward. One thing to note in C++ is that the assignment operator returns whatever that is assigned. So you can do something like this. As you can see here, C equals A plus B, return the value of C after it's being assigned, which is 9. And you can see in the output here. And if you print C again, C will have been assigned to 9. So you see 9 here also.
Hey, Sean, can you go back to the previous slides? So here, if you want to really enforce A to transform to float, I would suggest you to add another bracket to make them together, because that will have some ways that you will not get 0.5.
That's true. I forgot about that, because like I thought float, like the casting operator always binds tighter than everything else, doesn't it?
I don't think so. I'm not sure, because I always have the habit that I would make them together by a bracket to just in case. I don't want to get this risk. It will be very, very difficult to debug if you have this kind of.
That's very true. Whenever unsure, resist temptation to guess.
Yeah, that's the best way to do the safest way. At least you won't get into trouble.
That's very true.
Yeah.
That's fine. There it is. Oh, okay. Okay. Where am I? Can't see again. Get the. All right. I think this is where I'm at. Oftentimes, you like to modify a variable with another variable. So like A equals A plus B, etc. And because we do that so often, C++ give us a shorthand way of writing it, just to make it a bit more convenient for us. So here you can see the shorthand version of A equals A plus B is A plus equals B, and for A equals A minus B, it's A minus equals B, and so on and so forth. Right. That brings us to the increment and decrement operator. I think this is something that's not done very well in other C++ tutorial. So hopefully I'm going to explain it a bit well and make it a bit clearer. Right. So we programmers like to do plus equals 1 and minus equals 1 very often, increment, decrement, especially when we need a counter variable, right? Which is everywhere. So of course, C++ give us shorthand versions of these things as well, as you can see here. The shorthand version of A plus equals 1 is plus plus A, and the shorthand version of A minus equals 1 is minus minus A. All of that should be straightforward, right? But now some people want to ask, what about A plus plus A minus minus? Are you going to talk about them? Yes, I'm going to talk about them. So recall that the assignment operator does return something. In this case, if A was 1, before it's going to return 2, right? 1 plus 1 equals 2. So that means A plus equals 1 will also return 2, and so will plus plus A. However, and here's the difference between A plus plus and plus plus A, is that in the case of A plus plus, it will actually return 1. It returns the value of A before the increment. So here's a piece of code to show what I mean by this. As you can see in the comment here, A equals 1 plus plus A will give you a 2, return you a 2, whereas A equals 1, A plus plus will evaluate to a 1. Now, A will obviously still get incremented, so we see 2 being printed on the next line in terms of A plus plus. And the same goes for A minus minus and minus minus A. If A equals 1, A minus minus will evaluate to 1, it will get incremented 2. Whereas A equals 1 minus minus A, this will evaluate to 0. Sorry, A minus minus will also get decremented to 0. Minus minus A will evaluate to 0, and A will get decremented. 0. I hope that makes sense.
Oh, that's here. I can add some interesting knowledge. Can you go back to here? So do you know the efficiency difference between the plus plus and the plus plus A and A plus plus?
I imagine plus plus A will be more efficient, or I don't know.
Yeah, your imagination is good. Is correct. Yeah, plus plus A would be more efficient. If you check the underlying implementation of this overload of this operator, you can see that in the A plus plus, there is actually a copied operation in the implementation. That means there is a local variable that you copy the current value of A to a local variable just in case for the return, and then to increase the value of A, and then to return the copied original value here. Yeah. And then the plus plus A do not have this value copy. So if you have a large for loop here, so I would suggest to use plus plus rather than the plus plus I for in general. So we will use rather than I plus plus. So that's still some efficiency issue.
Yeah. But most of the compiler should optimize it though. If like the return value isn't used.
That's true, but as a what I prefer we should control everything by ourselves rather than rely on the compiler. What if the compiler
doesn't optimize it? Yeah,
it's our program by ourselves. So that's some philosophy of in programming how to make it extremely efficient.
that is extremely interesting. Thank you.
Okay, just so we.
All right. Okay. Okay, my internet connection is unstable. You guys can still hear me fine, right? This says here my internet. Okay, never mind. Let's keep moving. Comparison operators. So we have equal equals, not equals, bigger than, less than, greater than or equal to, or less than or equal to. They mean exactly what you think they mean. So yeah, this should all be very obvious and straightforward here. Logical operators, we have and, or not. Yeah. Again, they do exactly what you think they do, as you can see in this table. So should be no surprises here. Right, C++ operator does have precedence. So as Junhao mentioned before, sometimes even I don't know which one comes first. Most of the time, they are what you think they are. Like for example, multiplication and division and the remainder operator takes precedence over plus and minus, right? So that should be no surprise here. If you are unsure about the precedence, search it up or use some brackets, as Junhao pointed to me earlier. Always resist the temptation to guess. So in C++, bracket also does exactly what you think they do. Right, now we're done with operators. I'll just very briefly mention that you can initialize a variable when you're declaring it. So as you can see here, instead of int a equals 1, you could just do int a equals 1. You can also declare multiple variables with the same type in a single statement, as you probably already seen on previous slide. And you can choose to initialize some of them. So here you can see in this very tiny example, I've declared 3 ints, A, B, and C, and I've initialized C to 1. Well, another thing that I tried not to mention, but it turns out it's actually kind of necessary to mention, is auto. So this is basically telling C++ to infer the type for you. If you use it, obviously you have to initialize the variable in the same statement, right? And then the type of the value that you initialize the variable to will become the type of the variable, right? Usually we don't really use this because sometimes you think the compiler infers something for you, but then they infers the other type and then you get confused and it's like, But yeah, sometimes the type name can get extremely long. I've seen type signatures that span 80 characters. So So in that scenario, you do not want to type the entire type signature out, and you would just use auto. Right, we're making progress. Control flow. Here's an example of a statement. Pretty much does exactly what you think it does. If A is 1, execute the first C out, otherwise execute the second C out. If the else branch is empty, you can omit it. So you don't have to type the else branch if there's nothing in it. And if you don't type it, it'll just do nothing when A isn't equal to 1, as many other languages also do. Else if in C++, else if is also extremely simple. So when you want to nest another if inside of an else branch, you can do an else if. So here in this example here, it first check the first if condition. If it doesn't match, then it goes to else, and then check the second if condition. If it match, then it execute the content of the second if branches. Otherwise, it goes to the next one. Should have seen this before again in other languages. So this should be fairly straightforward for most of you here. Right, that's out of the way. Let's move on to loops. So here we see an example of a while loop. Should be fairly straightforward. The way this works is that every iteration, it checks the condition on top. If it is true, it executes the content of the loop, otherwise exit the loop. So here we can see if we run this loop and give it an input of 10, this would be its output. I hope this all makes sense. Right, so for this kind of loop with a counter variable, it's fairly tedious to write it in a while loop. And we use counter variable. We use this kind of +1 every iteration very often. So C++ does give us some syntactic sugar, and that is a for loop. You probably have seen this in other languages before. So here I've written an example of a for loop here, pretty much equivalent to the while loop on the right. You can see that we've basically put the declaration and the initialization of variable I and the incrementation of I on the first line of the loop. This is basically a prettier version of while loop on the right, except one tiny difference that I'm going to tell you right now. So those two loops are not exactly identical. And to tell you the only difference between these two loops, I have to tell you about scope first. So concept of scope can be summarized into a single sentence, and that is a variable can only be used in the curly braces that it is declared in. As I've made this tiny example just to show you exactly what I mean. Here you can see the variable A is declared in the curly braces with the main function. So it can be used anywhere inside the curly braces. I should probably point it out this one and this one, right? Variable A. Whereas B is declared in the curly braces in the if statement. So it can only be used within this curly braces. And you can see on the last line here, you can't use B outside of the curly braces here because it's out of scope, right? It's that this is not okay, whereas everything else is okay. So back to the two loops. The only difference between the while loop and the for loop shown in the example here is that for the for loop, variable I have a scope within the curly braces of the for loop. So, well, for the while loop, you can access I after the loop just like any other normal variable that's been declared there because I is a normal variable that's declared there. With the for loop, you can't because variable I is declared with the for loop. Therefore, it can only be accessed within the for loop. So this is for loops can like provide conveniences when you want to do a lot of like it limits your variable scope to the right places basically. Now break and continue. Sometimes you want to skip the rest of the loop and start the next iteration immediately. This is where the continue statement comes in. Continue statement basically says, all right, I don't want to execute the rest of the iteration. Let's start the next iteration immediately. Right. Sometimes you just want to jump straight out of the loop, and that's where the break statement comes in. It basically says, jump out of the loop. Just don't care about anything else, just jump out. So here you can see a little example. When I is divisible by 2, it skipped the last output statement. if I divisible by 5, it jumps out of the loop directly. And you can see in the output here. This is, my script is a bit wrong. So here's a little example that I wrote showing how continuous break works. And here's the output. I'll just run through the output here. You can see that in the, my cursor keep going to the wrong places. Okay, here it is. So you can see that in the first iteration, I is initialized to 0. So here's new line character here. And because 0 divided by 2 is remainder is 0, it continues, skip everything else, and then starts the next iteration. The next iteration, I get incremented to 1, and it prints another new line character there, right? I divide by 1 divided by 2 has a remainder not equals to 1, so this part doesn't get executed. I divide by 5 again has a remainder not equals to 1, so it doesn't break away from the loop either, and it prints out 1 as shown here. And then just keep looping until I divided by 5 has a remainder of 1. In this case, it breaks, jumps out of the loop, right? Even though I is still smaller than A, which is 10. Jumps out of the loop, and then it just prints loop finished. I hope that's a bit bumpy, but I hope that's clear. I hope that's clear. All right, something I need to mention on control flow is that if you give this if statement a number instead of a Boolean variable, so any non-zero number will be converted to true and 0 will be converted to false. So here you can see I've given the if statement the number 5 because 5 is non-zero. It gets converted to true, and the if statement will be executed. Something that's very annoying about this behavior, combined with the fact that assignment operator returns something, is that if you make a typo, when typing the comparison operator equal, and you type equal instead, the assignment operator, you basically get a bug, right? So as you can see in this example here, I initialize A as 1. What I wanted to type is A equals 2. So if A equals 2. But I make a typo and type A equals 2. So this is 2 assigned to A instead. What will happen is that recall the assignment operator, return what's being assigned. So here A equals 2 will first assign 2 to A, and then it will return to the if statement, which will be converted to true. And then the content of the if statement will be executed. This is very annoying because in this tiny example, it's very obvious what's going on, right? But if your solution to a complicated programming question have like 200 lines of code in it, you wouldn't know what's going on. You just be confused. And so this is something that you need to be particularly careful. As you can see here, Visual Studio doesn't even give me a warning, right? It just silently passes, assuming that this is what I wanted, whereas this is quite clearly a typo. Right, 2 other control flow that I've yet to talk about. Switch and do while. I don't think that they're relevant in terms of competitive programming, at least. I've never used switch or do while in a programming conversation. Most of the time I just use while with break and if else's. But yeah, you can look it up if you want, but in terms of competitive programming, I don't think that that's useful. Another thing about control flow is that there's only one statement. If there's only one statement in a if, while, or a for loop, you don't have to type the curly braces, right? So you can see on the top here, the if statement is the same as the bottom one. You only need curly braces when there's multiple statements in a loop or if branch. All right, that's pretty much all the control flow. Pointers, let's talk about pointers. So this is something that does not show up in languages except C and C++. It's basically a variable that stores an address of another variable. And to understand pointers, there are basically 2 operators that's relevant. The reference operator and the dereference operator, right? So what the reference operator does is that it gets the address of the variable, and the dereference operator will basically do the opposite, give you the variable that the pointer points to. So to better understand this, here's an example that I wrote. here you can see to declare a pointer pointing towards an integer, you basically do the exact same thing as you would declaring an integer, but you put the dereference operator in front of the variable name. The dereference operator is the asterisk here. And here, I've declared a pointer called PTR, right? And assigned the address. This is using use of the reference operator, assign the address of variable A to it. And here you can see the address of A is this hexadecimal number. And pointer now points towards A, whose value is 1. So here's the use of the dereference operator here. Now, if I change the variable that PTR is pointing towards to 10, you can see the dereference operator being used here. A will change too, because essentially they are the same piece of memory, right? As you can see in the output here. So I hope that's clear for pointers. Right, something else that I have to mention about pointer is that when you're declaring a pointer, the dereference operator binds with the variable name. Right, so what I mean by that is, for example, here in the first line, I've declared pointer PTR and the integer A. So the second variable A will be integer. If I want to declare 2 pointers, I have to write it out like the second line, right? I have to put a dereference operator in front of both variable names. Now, this isn't very confusing, but then sometimes you accidentally type it like the third line here. I know Visual Studio very annoyingly would automatically format everything to the format of the third line. So they will put the dereference operator with the type name. And you can see how this becomes a bit misleading. Here on the third line here, it looks like we've declared 2 integer pointers. Actually, we've only declared 1 pointer and 1 integer. I think that's all for pointers. There is something called a reference in C++. I'm not going to talk about it because it basically never come up in competitive programming. I've never used it personally, but you can look it up what a pointer, what a reference is if you want. So, arrays. Are we on time? Yes, we are. In C++, there are 2 types of arrays, static array and dynamic array. Let's talk about static array first because it's a bit simpler. So basically, static array are those whose size is determined before compiling. The size of the array has to be constant, right? That's like positive integer literal, not variables. Right. Here's an example of a static array. I basically just declare an array of size 10, then initialized it in a for loop, and then printed it out in another for loop. And here's the output. Should be fairly simple. I'm sure many of you have already seen similar syntax in other languages, hopefully. You can also have multi-dimensional arrays in C++. Here is a 2-dimensional array in example here. Again, I use the same for loop to initialize them, and then use some for loop to print them out. Should be no surprises here, and here's the output of the example. Here's the first part of the output for the example. Should be very intuitive. Right, now before I talk about dynamically allocated arrays, let's talk about the meaning of the indexing operator. Many people don't know this, but indexing operator in the context of C++ array is actually a syntactic trigger. So it's shorthand for something else. To understand this, we first have to understand that in this example here, ARR by itself kind of acts like a pointer, right? Pointer that points towards the first element of the array. So here in the second line and the third line are actually equivalent. They are the same thing. It's simply different way of writing the same thing. ARR fifth element can be found by using a pointer to the first element of the array, offset it by 5, and then dereference it, right? I hope that's clear. Now, that's out of the way. Let's talk about dynamically allocated array. I think after this, we should probably have a break. I'm getting a bit dry here, my throat. So dynamically allocated arrays and the new and delete keywords. Here's an example of a dynamically allocated arrays. I'll just go through this line by line. For the first 3 lines, we ask for a size of the array and then store it in variable n. And then after that, we declare a pointer called ARR, and we use the new keyword to allocate an array for it. So what the new keyword says is basically, give me a block of memory with the size that can accommodate n ints. Return me the pointer that points to the start of that block of memory. I hope that makes sense, right? I hope the new keyword makes sense. All right, so something about dynamically allocated memory is that you have to manually free them, right? So any non-dynamically allocated memory, so this includes normal variables, static arrays, any non-dynamically allocated memory, they get automatically freed when the scope of the variable ends, right, the end of the curly bracket. But for dynamically allocated array, the memory allocated doesn't really bind to any variables, right? So the pointer to that variable might be passed around in the program, and that's why we really have to tell the memory allocator, hey, we've done with this piece of memory, please have it back. And that's what the last statement does here. And then the memory allocator basically might give the memory to something else, etc. So if you do not free a piece of dynamically allocated array, what happens is that you get a memory leak. This is something, again, unique to C and C++, as far as I know. There's probably some other language that have memory leak as well. So what happens in the memory leak is that the memory allocators still think you're using that memory, but you actually already lost the pointer that points towards the memory. Nobody knows where that memory is. And then the memory allocators still think you're using it, and it kind of just become lost memory, right? That's why it's called a memory leak. Normally in competitive programming, this doesn't really matter because all the memory gets freed when the program terminates anyway. I don't think environment checks if you have a memory leak. But obviously, as I mentioned before, if you leak too much memory in your program, you might get a memory limit exceeded. So that's just something that you should keep in mind. So to free a dynamic allocated array, you use the delete keyword with the square bracket, and then after that, the pointer to the start of the array, as shown in the last line here. Something I have to mention here is that after you use the delete keyword on the pointer still exists after the delete keywords, right? But now it's pointing towards a memory that's already freed and could belong to something else. So this is actually something very dangerous called a dangling pointer. And I have a fairly interesting example about it after I've talked about function. So stay tuned. And I think now we're done with everything except functions and classes and then the library. Let's maybe take a 5-minute break. My throat's a bit sore here, so I should probably go have a rest. And I'll see you all in 103. Okay. Oh, yeah, we have 7 participants. Didn't notice that.
Okay, thanks, John. I think I have to go.
Yeah.
Thanks for the tutorial.
That's
Okay.
all good. You're like you're like a great guest tutor. Yeah, you said a lot of things that I don't even know, like the plus, like, wow, I didn't know that. Yeah. All right.
Okay.
Thank you.
Good. Bye, Aaron.
Yeah, I think I might have to leave as well. I would
Oh, unfortunate.
Yeah.
All right. Yeah.
By the way, is this going to be recorded? I could watch like after this point.
Yeah, everything is gonna be recorded. Everything. I'm gonna put on YouTube and then like market it and then make millions of dollars with the YouTube video.
I see. Well,
Okay.
Good plan.
All right. Okay.
Yeah. Thanks. Sir. Yeah,
All right. Thanks for coming.
Can I quickly ask?
Yeah.
So with these dynamically allocated arrays, what do you tend to use just static allocations, or you do actually use dynamic allocations
The
when you're
thing
running the
with
solutions?
the thing with static allocation is that you sometimes you don't know the size of your array beforehand, right? So like maybe you need an array of depending on the input. And with static array, you can't do that because with static array, the size of the array have to be determined before compiling, right? So that's before you started running the program. So that's why most of the time we do not use statically allocated array. We
Okay.
actually almost always use dynamically allocated array. Yes.
Okay. So it's not like they ever tell you the maximum number of inputs you'll have is 1,000, and then you could just use static and like a variable to track how many you actually use.
That's true. That's true. But like, what if the size of the input is? I don't know, But like, sometimes you don't want to allocate too much memory, or maybe the size of the input is m times n, right? And then they give m and n the maximum possible value, but then and multiplied by n might be actually the maximum of that might be small. So
Yeah.
you get what I mean, basically.
Then no, I do. All right, thank you.
Yeah, it's okay. All right, I guess let's keep going. I forgot about something before functions. Dynamically allocated 2D array. This is actually something pretty interesting. So dynamically allocated multi-dimensional array. For example, a 2D array, right? What you do is that you dynamically allocate an array of pointers. So this is a pointer to an int, right? And then you allocate an array of pointers. And then what you do is that you use a loop to allocate each pointer an array. And to free the memory that's of dynamic allocated to the array, what you do is that you need first a for loop to loop through the array of pointer, freeing the sub-arrays one by one, and then you free the overall array of the pointer at the end. Now that should hopefully be fairly straightforward. However, there is something that you need to know about multi-dimensional array is that there's differences between them and static array. So the thing about the static multi-dimensional array is that its underlying data structure is actually identical to a static one-dimensional array. So what that means is that the indexing for dynamic multi-dimensional arrays and static multi-dimensional arrays are really different. For dynamic array, it's exactly as you think it is, as the comment here says. First of all, you offset it to the place of the pointer that you have access, and you dereference that, offset again, dereference again, recursively offset and dereference it, right? However, for static multi-dimensional array, as shown in the comment here, it's actually indexed kind of like a 1D array, right? So you only offset it and dereference it once. So there are implications for this underlying structure. And the implication is that the type of a multi-dimensional array is actually quite funky, to say the least. You can see here the size of the 2D array in the example here is actually a part of its type, right? And the reason why this is important is that when I talk about function soon, and say you want to pass a statically allocated 2D array to a function, you have to specify the size of the array as part of your function signature, right? As a part of your parameter types. So that's just kind of inconvenient. Most of the time, we just we just use dynamically allocated 2D array, so we don't really mind. We pass pointer to pointer. So yeah, now functions. C++ functions are fairly straightforward. You've already seen the main function. Here we can see a function that takes an integer and then return that integer +1. I'll just explain what everything does in this function definition here. First, you define what the return type to this function is. So add1 returns int, And then you define the name of the function. Here its name is add1. And then you define its parameters. Here we're going to take in one parameter named a. And then after that, you put the body of the function in the curly braces. Here we increment a by 1 and return the incremented value of a, right? And we call this function in the main function. So we should get the output of 0 plus 1, which is 1, right? Except this doesn't work. And the reason why it doesn't work is when C++ is invented, compiler was still quite old and stupid. So a C++ compiler will read the code line by line. And then when it sees add1a being called here in the main function here, it doesn't know what it's looking at because it reads it line by line. It hasn't seen the add1 function at that point. So there's two ways to get around it. One way is simply put the add1 function on top of the main function. This is what we do most of the time in competitive programming because we don't want to type as much. And if we do that, when the compiler come across the add1 in the main function, it'll know what it's looking at because you already seen the add1 function before, right? And so now everything works. However, sometimes you can't do this. For example, if function A calls function B and then function B calls function A, right? Whichever one you put first wouldn't be able to call the other one, right? So, and also this is just bad co-organization, right? Sometimes we do want to put the function in our preferred order. Usually we want to put the main function first and then have all the other function in terms of non-competitive programming anyway. Competitive programming, we don't really care. So sometimes putting the function this way is really just quite messy. So another way to get around this problem is to do something called a forward declaration. So what this is that to first declare the function before it's used, and then you can put the definition wherever you want. So the way you declare a function, you do a forward declaration of a function, is just to take the first line of the function here, and then copy paste it, add a semicolon to the end, and then put it on the top. That's it, right? As shown in this example, and now everything will work because when C++ sees add1 being called in the main function here, it will know that this is the function because you already seen the declaration before, so everything will work. Right, now let's talk about pass by values. So all C++ functions pass by values by default, except array, because array itself kind of acts like a pointer, so it's always passed by reference. So what does that mean is that when a variable is passed to a function, it's copied, right? So whatever happened with the variable inside the function doesn't affect the variable outside the function, right? So here you see, even though n inside the function got incremented to 1, the variable outside of the function will still be 0. Right. You can ask C++ to make your function pass by reference. So to do that, you basically put the reference operator before the variable name to tell C++, do not copy the parameter, just give me the parameter itself. This is basically never done in competitive programming. Usually you use a pointer, right? Which in my opinion is better because your intention is clearer. But I'm telling you this because you might come across some function in the standard library in C++ that is passed by reference, and they will sometimes modify your variable. One example for that is cin. So cin takes in the reference of the variable that you give to them, and that's how they modify as they give input, right? So now this is all for function. Actually, it's not. It's still template function, but this is all for normal functions. Let's talk about something interesting, namely dangling pointers. So in this example here, I have a function called foo. What this function does is that it first declares a variable, initialize it to 10, and then return the pointer to that variable, right? And outside in the main function, I called foo, right? Store what it returns. Yeah, outside foo in the main function, I called it, right? Store what it returns in the pointer variable called ptr, and then I print what ptr points towards, right? And now I declare a new variable b, initialize it to 20, and I print what PTR is pointed towards again. So now we only have 2 people here, so we can't really do this, but I'll try anyway. Who can try to guess what this piece of code will print? Just guess the output. Anyone? Guess. I mean, there's only 2 people here. I'm not really expecting that much. Oh yes.
Is it the address of A?
What you mean the first line?
Yeah, so it passes this pointer, which is foo. So it calls the function foo,
Yeah.
and that foo function returns the address of A. So that's what goes to C out.
Yes, but except there's a dereference operator set. So here you should actually get A. Right? Yeah, does that make sense? And maybe I didn't make it that clear about the reference operator. Yeah. But then what's interesting isn't what prints out here, is actually what gets printed out here. Because there's something interesting out here. Anyone know? I mean, there's only 2 people. So if you don't know, it's fine.
Okay. But sorry, just with that address of A, doesn't A is a local variable for foo?
Yes, that was going to be my point.
Like, doesn't it get destroyed when it returns?
It does get destroyed, but then what do you think the output would be? This code was still run. It wouldn't like print error or anything. There will be output, but what do you think it will be?
Well, who knows?
What?
Like, isn't it dependent if something else is overwritten A in the meantime?
Yes, that's true. That's true. I'll just show you. I'll just show you. So this is the output. Does it make sense to you? Rob? No? Yes. I just no?
Maybe explain it.
Yes, I will explain. Okay. Okay, fair enough. I was expecting you to do this with 4 more people. Yeah. Okay. So this is what it prints out, and I'll explain why. Recall that a variable is only valid, as you said, within its scope. So for variable A, that's appearing full, right? After full exit, it basically ceases to exist. So the memory gets free, right? So then when we assign its address to the pointer is now pointing to a piece of memory that could belong to anyone, right? And if for the first output there, anything has yet to be written to the part of memory, so nothing happens. But then after int b equals to 20, the memory does get modified because now a part of that memory gets allocated to b, right? And then b got initialized to 10. So the memory changed in an unpredictable way. So I hope that makes sense. Does it make sense? I hope it makes sense. Right. So this is really something to watch out for, not only in competitive programming, but just in general when you're working with C++ and C. It really does give you a very unpredictable behavior. A way to avoid this is that this dangling pointer is whenever a pointer is pointing towards some memory that isn't valid, just set it to nil. So nil is this special value that signify a pointer isn't pointing towards anything. So after you assign a pointer to nil, assign nil to a pointer, if you try again to dereference the pointer or do something you're not supposed to do, maybe you try to index it like an array, C++ will give you an error instead of silently giving you the wrong result. Right. Oof, we're making progress. Let's talk about overloading and template. You practically never have to write your own template function in competitive programming. However, I think it's important to understand what a template is so that when you're using template in the standard library, and then you will use template in the standard library, you understand what you're doing. So here's an example function. Divide and take 2 integers. Right. Divide takes 2 integers. Divide one of them by another and output the result. It should be a fairly straightforward function. So this all look well and good, except there is one problem, and that is that when I give the function 2 doubles, it only output the integer to me. And the reason for this is that the input parameter for this function are ints, right? So even though A and B are double, when they're taken as input for the function, they get implicitly converted to ints. And then an int division happens, and then the result gets returned, right? But what if you want division to happen as a double, right? And you want to get a double as an output. So you can do that. And that's something that probably exists in many, many other languages. Well, I know it doesn't exist in C, and it's called function overloading. So overloading basically means you write two functions with the same name, but with parameter of different types, or sometimes even different numbers of parameter. And C++ will call the appropriate function, depending on the type and the amount of parameter being provided, right? This should be fairly straightforward. The combination of a function name and its input parameter are called a function signature. It's kind of like a unique identifier for functions. So you can see in this example here, I wrote two versions of the same function, one double version and an int version. However, copying the entire function just because of a change of type could be rather tedious. Also, just bad coding style. Imagine if the function is hundreds of lines long and you have to change every single type and you have to copy them for every type. Like, no, right? So we would like to write the function only once and make it be able to use with any type we'd like. And there's a way to do that in C++. Of course, C++ can do anything. It's called templating. So here's an example of a template function in C++. All you do is put template class T on top of the function definition and declaration. And what this does is tell C++, hey, this is a template. And in this template, I'm going to use this type called T. And this T can be any type, right? So now, when C++ see the divide function being called in the main function, you look at the type of the parameters, which are doubles. And what it will do is that it'll know we want the double version of the function. It'll basically generate a double version of the division function for us. And so that's how templating works. That's why it's called template, because C++ use the template, generate an entire new function for us, and then use that function for us. Do I have other stuff? Oh yeah, I do have a slide. Okay. What you can also do is that you can specify the type you want for C. Right. So in this instance, let's say for whatever reason, I specifically want an integer version of my division function. You can do that too by putting int within the pointy brackets of between the function name and the parameter list. And C++ will generate an int version of the divide function, and you'll be able to do integer division. Again, quite happy, I hope. So is there any question about function and template?
Is it like good practice to always specify the int or the double when you call these templated functions?
Yes, that is so true. Yes, you want to, because that's clear. That's just more information for you to read. And a lot of the time, C++ actually cannot infer the type. For example, if divide doesn't take in a parameter, then it doesn't know, right? Or maybe you give divide a double and the int, and then you're not really sure which one is going to infer. You're like, so yes, you're right. Always put the pointy bracket in and then put the type inside. Right, I'm assuming there's no other questions. So we'll just move on to class. We are making progress, but we're also doing fairly badly. Actually, we might be able to make it within 2 hours. We'll see. Class. This is why C++ exists, because people wanted class with their C program. The class in C++ is also very straightforward. Here's just a little example class I created called array ARR of 3. As the name suggests, this is a class that contains an array, static array of 3. There's a private property here, int ARR3, a size 3 array of int, and 2 public functions, get function and a set function. There's 2 ways you can instantiate this class. One way is to statically allocate some memory for the class. So you can declare this just like you declare any other variable, and C++ will give you a piece of memory that give you this that allow you to instantiate the class. And then you can also dynamically allocate a piece of memory for your class, right? And assign its address to a pointer, right? So I hope all of this makes sense. That should be very straightforward. Now let's try to do something with our class. Right, okay. To access a member of a class in C++ is fairly straightforward. Again, you've probably seen this in some of the other languages. If you come from C in a class, if you come from C, a class in C++ is basically a struct in C, but with extra steps, right? Struct with extra steps. So use the member access syntax, which is basically a dot, and you can access a member of a class, right? In this case, I can access the member function set to set the second element of the array to 10, and then print out the second element of the array, which will be 10, right? So you can see the output here. Hopefully that's clear. Output here, right? But what about a pointer to a class instance, right? In our case, dynamic AR. How do you access a member of that? Well, one very straightforward way is just to dereference the pointer using a dereference operator, and then do exactly the same as we did with static AR instance. However, you can see that this is a bit tedious because the member access operator actually binds tighter than a dereference operator. So you have to put a bracket there, and then it's not very pretty. It's also not very clear what you're doing here. So what we can do is to use another syntax given by C++ specifically for the situation that is a lot more prettier and elegant, and that is with the arrow operator. So the arrow operator is just made up of a hyphen and a right pointy bracket that looks like the arrow. That's why it's called the arrow operator. If you already know C, you probably already seen this syntax. It's basically the same as the arrow operator in C. Right, another thing I have to talk about with class is that dynamically allocated classes, just like any other dynamically allocated memory, you have to manually free the memory. This time without a square bracket because it's not an array, right? So pretty similar to how you free the dynamically allocated array. Right, let's add a constructor to our class. We're still doing all right for time. Constructor in C++ are basically special functions that get called every time a class is instantiated. Again, you've probably seen this in other languages as well. As you can see in this example, to create a constructor function, you basically type out the name of the class followed by the parameter list, just like any other function, and then the function body, right, which you can do whatever you want when you want to initialize the class. In this case of the constructor, the name is kind of also its return type. So that's like one way to remember how to write a constructor is that the constructor kind of doesn't have a name. The name is the return type of the constructor. So this constructor I've written in this example here, it's called a default constructor. Reason being that it's the constructor with no parameters. So it kind of get called by default, right? The thing with default constructor for C++ is that if a class has no developer-defined constructor, conceptually, or sometimes actually, C++ will generate an empty default constructor for that class, right? So conceptually, every C++ in a class has a constructor. It's just that if you don't define them, they're empty, right? I hope that makes sense. Another thing to mention about C++ is that it also has something called a destructor. So that's a special function that gets called whenever a C++ object gets destroyed, either because the variable is out of scope or because we call delete on a dynamically allocated object. You don't really have to write your own destructor in competitive programming. I'm just letting you know that it exists because some classes we are come across in the standard library do obviously have dynamic memory allocation under the hood. So I'm just telling you this destructor exists, so you know that all those dynamically allocated memory doesn't get leaked. They get freed by the destructor written in the standard library. I hope that's clear. All right, let's add another constructor to our AR of 3 class. This time a constructor with 3 parameters. So you can have multiple constructors for a class in C++, just like you can overload your functions, right? Same name, different parameters. Hope that will make sense. On the right, in the main function, I've written a number of examples of how to call constructor in C++. I have to split the screenshot because one screenshot is a bit too tiny. So as you can see, For dynamically allocated instances, there's two different ways of calling the default constructor. You can either call it like you calling a function, so that's the second line here, or you can just do nothing and you'll get called by default, right? And just one way of calling the parameterized constructor like a function as shown here. In terms of static instances, it's a bit weird. There's only one way to call the default constructor, and that is this way, the way without the bracket. Reason being that if you put a bracket like that, like this shown here, C++, they get confused and then it starts thinking that it's a function declaration. So that's why it doesn't work. And then, yeah, so that's quite weird to say the least. And then after that, there's one way to call a parameterized constructor for static instances as shown here. Right. There's actually a lot of other ways to call a constructor, especially when the constructor only have a single parameters. There's like 6 different syntax to doing that. I'm just not going to get into them because they're not really relevant in terms of competitive programming, and you don't really use them at all. I've never used most of them. Right, another thing I want to mention is that if you want to use a class before its definition, you can't, because even with the forward declaration, C++ will still complain about incomplete type. So this is just something to keep in mind writing your own class, is that you have to put the definition of the class at the top. There are ways to get around that when you have two classes. Class A have a pointer to class B has a pointer to class A. Just like quite complicated way to like not put a function inside the class, or you have a messy whole chunk of mess. I'm not going to get into that. That's not relevant for competitive programming, right? So just to remember that if you want to create a class, you still have to put the definition of the class at the top. Right, let's talk about template again. Template class, you will see them in standard library. So say we want our AR3 class to be able to hold arrays of any type. What you can do, quite similar to functional template, is that you can make it a template, right? So here's an example that does exactly just that. We simply put template class T before the class and replace every int with T, right? And now it will be able to hold an array of 3 of any data types. Here's the same example of the templated version of AR3 class alongside with the main function. To instantiate a template class, you have to provide your desired type in the pointing bracket after the type name, just like with function template. Now note that the type you provided for a template class becomes a part of the type for your variables, right? What I mean by that is that obviously AR3 int can't be the input of a function that require AR3 float. So in this case, int and float, they both become a part of the type signature. And again, every time you instantiate a template class with a new type, for example, on the first line here, we instantiated our template class with int, C++ will generate an entirely new class, replacing every instances of T with int, just like template functions. Template is actually a lot. There's just a lot more to template. Template in C++, interestingly, is Turing complete. Just a fun fact there. So yeah, this is all you need to know. Again, you never write template in competitive programming, and you just use template written by other people in the standard library. So yeah, pretty much every single question you need to start from the standard library, and a lot of stuff in template in our template, as I've said there. Right, the last bit of syntax, operator overloading. We've come a long way. Again, just like templates classes, you never have to write your own operator overloading function in competitive programming. I'm just showing you how it works so you won't be confused when you come across it in the standard library. There's a lot of operator overloading in the standard library. Here's the same class as shown before, except this time with the operator plus equals being overloaded, as you can see here. Right, so before I explain more about operator overloading, I probably need to explain this to you. So that this keyword, many of you might have already seen this in other languages, such as Java. I know Python uses self instead of this. So this keyword is basically a pointer to the instance that's invoking the member function, right? I've made another example in the get function. So in this case, when ARR1.get gets called here, this will basically point to ARR1, right? Usually we don't explicitly type out this because C++ understand that we're referring to the current object. But at the end of the operator plus equals function, I do have to type it out because I do need to return the current object, and there's no other way to refer to the current objects. That's why. Right. So operator overloading, you can kind of understand it as a special function that gets called when we use operator with the instance of the class. So in C++, to overload operator, you just define the member function with the name of the operator followed by whatever operator you want to overload. So in this case, operator plus equals. This is the name of the function. Right, and then you type out the parameter. Usually, there's only one parameter, depends on what kind of operator you're overloading, right? And the other side of the operator is usually just the current object. Then to call this function, you can either call it like a normal function, like as we can see here, right? But then obviously that would be pretty pointless because why would you overload operator if you just write a normal function? So you can also call operator function by just using the operator, right? As shown in the example in the main function there. So the calling as a normal function will be equivalent to using the operator, right? Those two are equivalent. They are exactly the same thing, just different syntax. And there's the output. As you can see, because we called it twice, it is printed out twice. Oh, yeah, those two are the constructor of those two. And then because we call it twice, it's 6 plus here, 6 plus here, 6 here, and then plus 6 again. So that's 18. So that's operator overloading. And before I move on, I need to show you this example here. So here I've declared a very simple class that contains a pointer to an int, right? And in the constructor, I allocated a piece of memory to this pointer and initialized it to 0, right? And then I also defined a function called not modifying. In the function, it modifies the value of the pointer that is pointing towards to 10. And then in the main function here, I create an instance of the pointer class called PTR, print out the content of the pointer, call the non-modifying function, and then print it out again. As you can see in the output here, it gets modified. So I hope it's clear why it gets modified, even though C++ copied the instance as it's passing to the function, right? Passed by values. It only copies the pointer. It doesn't make a separate piece of copy of a new memory for the new pointer to point towards. So when the instance gets modified inside the function, well, not the instance in this case, but the places where the instance pointer points towards get modified, you can see the outside instance get changed as well. My point of showing you this extremely tiny example is that sometimes you pass an object by value and you think the entire object is copied, but actually inside the object, there's some pointers. Not everything is copied and your function start doing something that it's not supposed to do, right? This is just something that I want you to keep in mind just to be safe. As far as I know, there isn't anything in the standard library that would actually do this because the standard library, as you would have guessed, is extremely well written. They have something called a copy constructor that makes sure everything gets copied. So with the standard library, as far as I know, this kind of scenario would never arise. But if you're going to write your own class or you're going to use some other library, this is something that you want to be careful about. So, that's all for syntax. We're on the final stretch. Let's talk about standard library. So, 3 classes in the standard library that, in my opinion, are the most used in competitive programming. There's the string class, obviously, and the vector class. So this is basically an array list if you come from Java, and a list if you come from Python, and an unloader map, which is basically a hash map. String. Here's an example that I basically stole from the internet and also wrote some myself. I have to split this example up because otherwise everything will be way too tiny. First of all, if you want to use string, you have to include the string header as shown here. Just like you have to include IO string for seeing and see out. In this example, as you can see, you can construct a string out of a string literal. Note, so this I'm talking about the main function here. Note that string and string literal are very different things. String is object, as I've said before, whereas a string literal is just a sequence of char, right? So after that, you can see the first seeing here, we're taking a string as input. Now, something interesting about seeing is that it separates input by white space. So even though I typed hi there, it only took in hi because after that I saw white space and basically treated everything else as another input. Right, after that, in the second cout, you can see you can copy a string. So string does overload the assignment operator. This is not an example of operator overloading. When you copy a string, it actually copies everything, right? After that, we can see you can concatenate a string with the plus sign. So this is another example of operator overloading, right? String overload the plus operator. And then after that, we can see we can get the size of a string by calling the member function size, right? As you can see, after the concatenation, string 3 had a size of 10, as the output also shows. After that, we see that you can index a string just like how you would index an array. So this is another example of operator overloading. This time the string is overloading the indexing operator. You see how often operator overloading come up in the standard library. And then after that, you can see you can also append to a string, right? So again, operator overloading plus equals append. So yeah. And you can see the appending taking effect in the output here, I think. Yeah, here. There you go. Here. After that,
are strings immutable?
they are not. Did you know this?
No.
I mean, even in C, they're not. Even in Java, they're not immutable. Oh, actually, I don't know.
Java, they're immutable.
Okay, well, in C++, they're not, unfortunately. You can modify them.
Okay.
Yeah, yeah, I know. I mean, slightly faster, right? You don't have to copy a string every time you want to modify it. So I guess that's one advantage. Maybe. All right, I guess I move on. After that, after appending, we can see that you take, oh yeah, where am I? Oh, insert, right. After that, we can see you can insert a string literal into a string, right? So here, I've inserted a string of a single space at index 5, and you can see it taking effect in the output here. And then after that, we can see that you can take a substring of a string, right? So that will be using the substr member function. As you can see here, I've taken a substring of str3 from index 0 to 5, and you can see printed in the output here from 0 to 5 is hello. Another thing you can do is that you can find a substring in a string. So here I try to find the string word. As you can see in the output here, substring word start says index 6. That's pretty much everything about string. There's some other thing you can do with string, but they're honestly not that relevant in terms of competitive programming. You can look at them if you want in the documentation. Just Google C++ string. Well, string class in case they show you the result of string literal. Google is a very important skill for programmers. Let's move on to vectors. We're almost there. My throat really hurts. Okay, vectors. A vectors is basically like a resizable array. It's something that's very, very convenient to use. If you've done Python, it's a list. If you've done Java, it's an array list. Right. First thing first, you have to again include the header for the vector as shown here, just like with the string, hashtag include vector. Another thing about vector is that it is a template. So obviously you don't want the vector class to only work with one type. So you see a lot of template syntax here as I use vectors for string throughout this example here. Where's my vector? There it is, vectors of string, yes. All right, in this example, I first declare a function. So that's the one on the left here that prints a vector. As you can see in the condition of the for loop, there's also the size member function here. So this is the same as string. You can get the size of the vector with the function, pretty similar to other languages. So this is another example of where I think I just skipped the line. Yeah, right. Get the size of the vector with the function. I'm getting tired. After that, inside the for loop, we can see that you can index a vector just like you index a string. So this is another example of operator overloading. Just like with string, we overload the indexing operator. So what this printVec that I defined here do is basically takes a vector, prints out the vector of the element of the vector one by one with space between them, and then after that prints out the new line character. Right, let's talk about what's in the main function. So vector does have a default constructor, just like a string. You can see on the first line here, I am calling a default constructor to instantiate the vector for me. That's empty. After that, we can see we can append to a vector by using the member function pushback. So this is pushed back. So here I've appended 3 elements here: hello, word, and exclamation mark. You can see the effect of pushback function in the output here. Hello, word, right? And after that, we can see that we can remove the last element of the vector with pop back. Right? So popped back, and you can see it taking effect here. Interestingly, with this pop back function, it actually returns nothing. So it does not return the popped element to you, unlike many other pop function would do. So that's a bit weird. Again, we can see pop back function taking effect as in the input here, as I've already said. Right. After that, we can see that if a vector is empty, by calling after that, we can see if a vector is empty by calling on the member function empty. This will basically return true if it is empty, and if it isn't empty, it's going to return false. As you can see in the output here, obviously vec1 isn't empty because it has hello world in it. Yeah. After that, we see an example of a parameterized constructor for vector. This one takes 2 parameters, and what it does is that it creates a vector of size 4. So that's the first parameter here, and then fills it with string ha, ha. So that's the second parameter here. And right, so we can see the output of vector 2 printed out here. To print it out here. Yes, right here. Ha 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 ha. There you go. Okay. After that, we see the copy constructor in use. So, oops. What this does is that it simply copies all the element in vec1 to vec3, right? Use that to create vec2. So we can see the output, the content of vec3 is exactly the same as vec1. After that, we see you can insert in the middle of a vector. In this case, it's a bit weird. C++ doesn't really give you a clean way to insert. We have to use what's called an iterator. I'll talk about iterators soon, before hash map. So, but for now, just remember iterator as kind of a pointer that points towards something. Right, so what we need is an iterator that points towards the place where we want to insert. Luckily, there's a member function that does that, called begin. Right, so what we do is that we use the member function begin to get the iterator that points to the beginning of the vector, and then we just offset the position we want to insert, right? So in this case, I want to insert at index 1, so I go vec1.insert vec1 begin, so that's the iterator pointing to the start of the vector, and then +1 because we want to insert that index 1, and then comma, because the second parameter here, and then the element that we want to insert, which is the string there. So you can see in the output here of the insertion taking effect. Oof, everything about vector. That is pretty much everything about vectors. There are other things, again, there are other things that a vector can do, but this is most of the things that's relevant. Very useful data structure here. I personally use a lot, and we're almost done. Okay. So before I talk about our ordered map, we have to talk about iterator. This is something I've been trying to avoid to talk about because I don't want to make this workshop too long, but I guess we're doing fine. As it turns out, iterator is very important concept everywhere. So, and also I can't talk about ordered map without talking about iterators. Very briefly, copying from Wikipedia, an iterator is an object that enables programmers to traverse a container. This is probably not that helpful. In C++, you pretty much consider iterator as a pointer that can only be incremented, right? So you can plus something to iterator, but you cannot iterator minus something. You can't do iterator minus minus. That's not possible. In fact, in C++, iterator is specifically designed to act to resemble the syntax of a pointer. They do like operator overloading and stuff. And you can see the iterator in action as I talk about unordered map. All right, let's move on to unordered map, aka hash map, the last slide of this workshop. So unordered map is fairly simple. There isn't a lot of things that you need to know. However, there is some pretty weird stuff that happens with unordered map, unfortunately. So first of all, obviously you need to include the header for unordered map, just like a string and vector, right? So here, hashtag include unordered map as shown in the slide here. Unordered map is also a template, just like a vector. It can work with any types of key or value. In this example, at the start of the main function here, I've instantiated an unordered map with string as a key and int as a value, just for the sake of examples. Unordered map has syntax that's pretty similar to a dictionary in Python, mostly thanks to operator overloading again. You see how much they come up. It's just really great. As you can see in the second line of the main function here, we can index an unordered map with its key using the indexing operator, just like a dictionary in Python. You can also access or insert a member this way. After that, we see that you get the number of entries in an unordered map by using the member function size, as you can see in the output here. Size of one entry, because I only put one in there. Right, after that, you can see two ways of checking if a key exists in an unordered map. This is something that's pretty ugly about an unordered map. There's actually no direct way of checking if a key exists in an unordered map. However, you can do other things to get around it. One way is to use the member function find. So this will return you an iterator that points towards the entry with the corresponding key. If the key doesn't exist, then it returns you the very last iterator. So here we're checking that if it can find the key in the hash map. If it does find the key in the hash map, it will return something that's not the end iterator. And if it can't, it will return the last iterator, right, which can be obtained using the end member function. Right. After that, we see another way of checking if a key exists in our unordered map, and that is by count. Count is actually a bit more straightforward. You just provide key to it, and then it returns 1 if key exists, and 0 if key doesn't. This count is from, the name count is from like other container functions somewhere else in the standard library. It's for inheritance. I didn't talk about that, but yeah. So as you can see in the output here, the unordered map does contain the key high, and it does not contain the key hello, because we just insert key high and we haven't inserted anything about hello. Right. Another thing that's interesting here, as you might have noticed, that is that true and false value actually get printed out as 1 and 0. Very weird. Don't know why that happens, but oh well. After that, really see the iterator in action. This is, as far as I know, the only way to iterate over an unordered map. So what this for loop does is that it first gets the iterator that points towards the start of the unordered map here, right? In this case, we're using auto to determine its type here, because the actual type signature of an unordered map is like 80 characters long. So I'm not going to type that out. And also it's just unreadable, right? It's super long type signature for whatever reason. So yeah, I get the iterator that points toward the start of the unordered map. This kind of behaves like a pointer. Every iteration, I increment the iterator, right? And also, I increment the iterator so that it points towards the next entry in the unordered map. And I also check if it's reached the end in this condition here. If it hasn't, I keep looking. If it has, I exit the loop. So in the content of the loop, this is like last paragraph. In the content of the loop, you can see how we can access the key and the value of the unordered map. Here, the iterator is basically points towards what's called a pair. This is something that happens in Java, that exists in Java, I know. And we see that to get the key of the entry, we do an arrow operator. So this is again reminiscent of, probably not reminiscent, is probably not the right words, but you get my point. This is very similar to the pointer syntax that the iterator is trying to emulate here. So IT arrow first will get you the key, right? And to get the value of the entry, we do IT arrow second, and that will give you the value of the entry. So you can see there's only one entry in this order map because we only put one in there. As shown in the output, it's high 10. And at last, you can remove an entry by using the member function erase. So this should be fairly straightforward. You just provide the key to erase the function, and erase will remove the corresponding entry for you. That's the end of this workshop. Oh man. Guys, thank you for coming. Hello, Rod.
Hey, no, thank you. It was really handy.
Yeah, I prepared so much. No one will come. How sad.
I definitely got a lot out of it.
Yeah, I don't get paid to do this, you know. Anyway, that's done. I can go get some rest, and I'll put the recording up probably tonight. And thank you for coming.
Awesome.
And,
Can I just before you go, can I ask a couple of questions?
yes, ask questions.
So just in regards to your C++, what's like the file structure? So I know in Java you've kind of got one class and one file per class. Does that exist in C++?
Have you done C?
Yeah.
It's the same as C. Basically.
Okay, so you've got header files?
Yes. So our ordered map is actually header file. You don't see the .h there. I don't know why you don't see the .h there, but you don't. Yeah, basically, yes.
Okay. And do you write your own header files, or you just keep everything in one sort of main?
Presumably, well, if you're doing competitive programming, you only write one file.
Yeah,
right.
okay.
That is how it is, because it never gets bigger than one file. Obviously, if you're going to work with C++, yes, you do. You do write your header file. And writing a header file is like writing it with classes, just so complicated, more complicated than it should be, in my opinion, anyway. But yeah,
okay.
If you want, I don't even know how to write header file in C++. I only know how to write header file in C like last semester. Yeah.
Okay, so just keep everything in one file.
Yeah, well, I mean, in competitive programming, you always do that, right? So yeah.
And do you use classes just out of interest in competitive programming, or you kind of stick to functions?
You're asking if I write my own classes in competitive programming more often than I should.
Okay.
If not, like me personally, I write classes even when there isn't that necessary, just because, you know, OOP, right? Object programming. Yeah.
Well, it's a little bit easier, right?
Yeah, I know. You know, struct also exists in C++.
You've blown my mind. I kind of like struct though, to be honest.
No, struct in C++ is exactly identical to class. It is exactly the same thing. The only difference between them is that in class, everything is private by default, but in the struct, everything is public by default. I don't even know why struct exists in C++. It's very unnecessary. But
Yeah, that's a bit strange.
there's a lot
I
of things
thought-
that's very strange about C++.
But yeah, it's what everyone uses.
Yeah, I mean, in my opinion, clearly Rust is better. Even Java, even though it's slow, I prefer Java over C++ if I'm like write an app or something.
Yeah.
Oh well.
Yeah, what can you do?
Yeah, it's true. Yeah, I guess this workshop ends here.
No, that's awesome. Thanks so much.
It's
Been
okay.
really good.
It's sadly not what it's all right. I don't get paid for doing it anyway. All right. I'll end the workshop here. Hope to see you sometime.
All right. See you later. Thank you.
Bye.
Bye.